Let's take another design problem. Here, you are asked to design an SR latch using a 4 to 1 mux and some additional logic. So here is the truth table for the SR latch. We have the hold, reset, set, and the invalid states. I can simplify this truth table to the one on the right here. So when S is 0, R is 0, Q plus will just be the previous value. When S is 0, R is 1, Q plus will be 0. When S is 1, R is 0, Q plus will be 1. That's the set state. And S equals to 1, R equals to 1 are not allowed, basically. So how do we construct a 4 to 1 mux? So here's the process. First, draw the 4 to 1 mux. Ports are 0, 0, 0, 1, 1, 0, 1, 1. It has two select lines and 4 inputs, obviously, and 1 output. Remember, the set reset latch has two outputs, Q and Q prime. So if we are able to get Q, we can easily get Q prime by using a NOT gate. So let's see how to do this. So to program this mux, what I'm going to do is I'm going to use my select lines as S and R. So S and R are my select lines. Now let's fill in the inputs for the 4 to 1 mux. Let's go for the situation where S equals to 0, R equals to 1, which means we are selecting this port here. When S equals to 0 and R equals to 1, your Q plus is a 0. Therefore, we are going to program this as logic 0. Now let's look at the scenario where S is 1 and R is 0. S is 1 and R is 0 corresponds to this case. In this case, the output is 1. Therefore, we program this with logic 1. Now let's look at S is 0, R is 0. When S is 0, R is 0, that is a hold state. So it's just the previous value. And how do you get the previous value? You just take the feedback from here all the way up till here. Finally, we have S is equals to 1 and R equals to 1, which is the invalid combination. Typically, what they do is they are going to do this one here. So S equals to 0, R equals to 0, and S equals to 1, R equals to 1. They typically have the same inputs, that is Q. Since S equals to 1, R equals to 1 corresponds to an invalid state, you can either do that or you can connect it to logic 0 or you can connect it to logic 1 or you can just ground it. So this is the 4 to 1 mux and we still need Q prime. So I'm just going to take Q and inverse it. So that's Q prime. This is how you can build an SR latch using a 4 to 1 mux plus some additional logic.